5.1. In this video, we're going to learn many new concepts. So listen the video carefully. These are very important for your next classes for 9th standard and also for 10th standard. So listen these concepts. So first one we're going to see is the Pythagorean theorem. The Pythagorean theorem or simply Pythagoras theorem, named after the ancient Greek mathematician Pythagoras. So Pythagoras was lived between BC 570 to 495. Is one of the most famous celebrated theorems in mathematics. People have proved this theorem in numerous ways, possibly the most for any mathematical theorem. The proofs are very diverse, which include both geometric and algebraic methods dating back to thousands of years. So this Pythagoras theorem is very important in mathematics. In algebra and also in geometry, we are using this Pythagoras theorem to find the unknown side of a triangle. So statement of the theorem is, in a right angle triangle, the square on the hypotenuse is equal to the sum of the square of the other two sides. So listen carefully. In a right angle triangle, so Pythagoras theorem is in a right angle. So right angle means one of the angle is 90 degree. The square on the hypotenuse is equal to, so hypotenuse means longest side. So hypotenuse, for example, here BC is hypotenuse. So hypotenuse is equal to the sum of the squares on the other two sides. Sum of the squares, for example, here 4 unit means the squares, 4 square, 2 square, sum of the square of the other two sides. So here in angle ABC, BC square is equal to AB square plus AC square. So BC square is equal to AB square plus AC square. This is the theorem which found by Pythagoras. Sum of the other two sides of a triangle, right angle triangle, is equal to the hypotenuse square. Then visual illustration. So visual illustration is given. You go through the book, page number 167. Then converse of Pythagoras theorem. So converse of Pythagoras theorem, how to converse? If you see this, if in a triangle the square on the greatest side is equal to the sum of the square on the other two sides, then the triangle is right angle triangle. If a triangle, already I have told, sum of the other two sides is equal to the greatest side, hypotenuse side, some square of the hypotenuse side. See this example. In the triangle ABC, so triangle ABC, AB square plus AC square, AB square plus AC square is equal to, so 11 square plus 60 square. So 60 square is equal to, if we square and add this number, we will get 3721. It's equal to hypotenuse square, so 61 square. If you Square 61. 61 into 61. You will get this answer 3721. So hence we proved. Now the example sums have given. You go through the example sums. By using the Pythagoras theorem, we can find the distance or height of a figure or building by other two sets. If you see this example sum, the height of the ladder is given 20 feet and the height of the wall is given. We don't know the distance between ladder and the wall. We can find the distance between ladder and the wall by using the Pythagoras theorem. If you see by using this Pythagoras theorem, the scientists have found many distance. For example, distance of the mountain, distance of the moon, sun, moon, by using these theorems. So, if we see this proof, find LM, MN, LN, and also the area of triangle LON. So, we're going to find the area of LON, triangle LON. Area means this surface which is occupied by the closed figure. So, these are areas we're going to find from triangle LMO. If you see here, LMO, by Pythagoras theorem, LM square 1 square is equal to OL square minus OM square. So in Pythagoras theorem, we are adding the other two sides. Hypotenuse square side is equal to square of sum of other two sides. Now we are subtracting to find the LM. So LM square is equal to 25. So 25 means 5 units. So like this we are going to find from triangle NMO. So triangle NMO. Here also hypotenuse side is 15 square. So 15 square is equal to 12 square plus MN square. So MN is equal to 15 square minus 12 square. That means 225 minus 144 is equal to 81. The square root of 81 is 9 units. Now we can add all the sides, 14 units. Area of a triangle, we know the formula, half into base into height, half into base, 14 into 12. The answer is 84 square units. This sum is very important. So in exercise 5.1, 5.2, 5.3, we are solving the theoretical geometry. So you go through the concept. The concepts are very important. So you need to understand the concept. That's why I am explaining only the introduction part. So these are very important in theoretical geometry. Then only you can be able to solve the sum. Then point of concurrency. So what is point of concurrency? When two lines in a place cross each other, they are called intersecting lines. So intersecting, when two lines in a plane cross each other. So the two lines are intersecting at point O. So if we see, these two lines are intersecting at point O. Intersecting means the line passing through on another line. So intersecting point. Here L1 and L2 intersect at point O, and hence it is called the point of intersection. So point of intersection is O. Then three or more lines in a plane are said to be concurrent if all of them pass through the same point. So if two lines are passing through means intersecting point. If two or three or more lines, so in this sum more lines are passing through at a point. So this point O is called point of concurrency. A simple way, in a plane more than three lines are passing through a single point is called concurrency point, point of concurrency. Then medians of a triangle. So what is median? A median of a triangle is a line segment from a vertex to the midpoint of the side opposite the vertex. So from a vertex to the midpoint of the side opposite that vertex. In figure AM is a median of ABC. So in a triangle ABC, the median is a line which divides the vertex to the opposite length. So this is called median. So this vertex, the corner to the side, opposite side, corner to the opposite side. This is called what? Median. So how to find median? The example sum is there. In the exercise sum also we will see. The activities are there. You are free in this pandemic, so do the activities. In school days we don't have time to do the activity, but in this pandemic period you are free, do the activities, learn the introduction part. It will be more useful for you to prepare for the next class. Then centroid. So what is centroid? The point of concurrency of the three medians in a triangle is called its centroid. So first we had seen what is median. So median means vertex to the side of a triangle. So the three vertex, from the three vertex, so from B to AC, C to AB, this point is called median. I will read it once again. The point of concurrency of the three medians in a triangle is called its centroid. So centroid should be denoted by the letter, capital letter G. These are very important. So letter G. If they mention capital letter G means we can understand that that is a centroid. Then properties of the centroid of a triangle. So what are the properties we have in centroid? It is always located inside the triangle. So centroid is always located inside the triangle. So it will be inside the triangle only, not in the outside of a triangle. We have already seen that it serves as the center of gravity for any triangle lamina. So this place is center of a triangle. So if we take a distance, this is 5 centimeter means this is also 5 centimeter. GC also 5 centimeters. So it serves the center. Then observe the figure. The line drawn from each vertex of G from the three triangle, surprising the areas of these three triangles are equal. So the three triangles, if you see from the center, so the areas will be equal. So these are the properties we will play in the example sums. So these are very important. Then altitude of a triangle. So altitude of a triangle is also known as the height of the triangle. So altitude, you know that height of a triangle. This AD is altitude of a triangle. So in your higher classes, they will not say find the height of the triangle, find the distance from center to the vertex, like that. They will mention the geometrical term, find the altitude, find the centroid, like that. If you know the definitions only, you can able to solve the sum. Then perpendicular bisector of a triangle. So perpendicular bisector is nothing. See here. So perpendicular line means a line segment. L is perpendicular to AB. It touches or passes through the another line. Then bisector means cuts. So perpendicular bisector means line segment L to bisector to XY. Then L2 is also perpendicular to XY. M is the midpoint. So this is midpoint, 90 degree. So perpendicular bisector as always 90 degree. The perpendicular bisector of the sides of any triangle are concurrent. Then circumcenter. The point of the concurrency of the three perpendicular bisector of a triangle is called its circumcenter. So circumcenter means the point of the concurrence of the three perpendicular bisectors of a triangle, called its circumcenter, denoted by the S. So this is called S. If you place the compass and draw a circle that will touch all the end vertex of a triangle, that is was circumcenter. So this is enough for today's class. Then angle bisector of a triangle is that these are we will use in the geometry, practical geometry, and also in theoretical geometry, finding angle, finding the distance, finding the midpoint. So you go through all the definitions of exercise 5.2. Then we will see do the exercise sum in the next video. Thank you, students. Have a good day.